Hello everyone, in this video I'm going to be talking about changes between the states of matter, the three that we deal with at key stage 3 and 4, the solid, liquid and gas. So we're going to talk about the particle arrangement in all three types of matter, the name of the process for being able to switch from one to another. I'm going to look at actually what happens to those particles when we move between those three states, or phases as they're sometimes called. So let's start with the pictures that I have on this slide. So you can see in the solid over to the left, the particles have a fixed arrangement and they're very, very close together. If we compare that with a liquid, we can see that those blue particles, they're still quite close together, but they're not in some fixed solid arrangement. Both the solid and liquid do have fixed volumes, but we can see that the solid has a fixed shape, whereas the liquid doesn't. And then with a gas, you can see those red particles have moved slightly further away. Then they don't have a fixed volume or a fixed shape. And there's a bigger distance between the two. So there is no fixed arrangement. They've started to spread out almost. So let's think about the name of the processes between the solid, the liquid and the gas. So let's look at this. In fact, we'll label them one by one. So if we go from solid to liquid, we'll call that process A. Process A represents, so when we're going from solid to liquid, and that would be melting. So to turn a solid into a liquid, we undergo melting. If we wanted to turn a liquid to a gas, we'll call that process B. So to go from liquid to gas, that would be boiling. So that's what process B is. So going from solid to liquid is melting, and going from liquid to gas is boiling. Now, as well as being called boiling, we can sometimes refer to that as evaporating. So when we go from liquid to a gas, as well as that being boiling, we can sometimes call that evaporating, so we'll put that in there. Now what if we were to go the other way? When we go from a gas to a liquid, so we'll call that process C, that is called condensation. So when we have condensation, we're able to turn the gas back into a liquid. And now let's put this one in place here. Let's go from liquid, we'll call that process D. When we go from liquid into a solid, that would be freezing. So for example, let's take water as our material. So A, when we go from solid to liquid, we're melting ice and turn into water. B, when we're going from water to steam, we're going from liquid to gas, so that would be boiling or evaporating. When we turn steam back into liquid, that's through condensation. And if we have liquid water and we want it to turn into a solid or ice, in this example, that would be freezing. Now there are the main four processes, but there are another two that we could put into place. I'm going to just shrink this a little to create a bit more room. There are two other processes that you don't often hear about, especially at key stage 3, more so at key stage 4. There is a way to go from solid directly into a gas. And likewise, there is a way to go from a gas straight back into a solid. So if we say solid to gas is process E, and we call going from gas to solid F, let's just talk about what E and F are, because E and F are kind of extra ones we don't tend to think about. process E, when we go from a solid to gas, is one known as sublimation. So through sublimation we can actually turn a solid directly into gas. And F is one even more infrequently spoke about in school, when we go from a gas to a solid directly. And that is called deposition. Now, let's think about actually what happens to the particles when we go from one phase to another. So we're going to just draw a graph down the right hand side, just a very quick sketch here. We'll put time on the bottom, on the x-axis, and up the side, on the y, we'll have temperature. And we'll have temperature in degrees C, we need to give it units, and we'll have time in, say, minutes, so it's good practice to put units on it. I'll just draw a very distinctive graph here. Now what I'd like to do is explain exactly where this graph comes from, because this is a very typical change of state graph showing the very distinct phases when we go from solid to liquid and liquid to gas. So I'm going to put a letter by each phase on this graph, and I'm going to explain exactly what is going on at a particle level. So we'll call this first bit A. This is separate from the A, B, C, D, E, F on the left hand side. So at A, so we're going to imagine taking a block of ice and we're going to turn that solid into liquid, then into gas. That's where we're going with this graph. So at A, in this portion of the graph, the substance is a solid. The particles are fixed in place and are vibrating. Let's just think about here at B. At B, the solid is hotter. The particles are vibrating more and the solid has started to expand. So we can see as time goes on and the temperature is rising, we're providing more kinetic energy to those particles, so they're starting to vibrate, move a little bit apart from one another. Then at C here, so just at that point where the graph starts to plateau, that's when the solid is starting to melt. Now, some of those particles have broken away from their fixed arrangement, and you'll notice the temperature has stopped going up, and that's because the heat energy is actually being used to break the bonds between the particles. So we're talking about this portion of the graph here. That's why there's no further rise, because heat energy is breaking those interparticle bonds so they can separate. And that's what's happening at C. D here, this point where the graph has started to rise again, that point, that's where the substance has completely melted. The particles are now moving around with no fixed arrangement. So we've changed state ultimately. We're into liquid territory now. So we've gone from our solid and now we're moving into liquid. So let's put E here. Let's talk about what's going on at E. And E, that liquid is hotter, because we can see as time goes on, the temperature is still rising. So when we increase the temperature at E, the liquid is hotter, the particles are moving around much faster now, and the liquid has expanded. So those particles, like we can see on the left-hand side of this whole screen, those particles have moved further apart. Those blue dots in the liquid picture that I've just been drawing previously, you can see there's gaps between them. They're moving apart from one another. Let's think about what's going on at F here. So the graph is starting to level out again at F. Now at F, the liquid is starting to evaporate. The temperature again has stopped going up because heat energy is being used to give the particles enough speed to escape from the liquid as such, to overcome those interparticle bonds between them. So F, that's when we're going from liquid into gas. Then we have G, which is this point here where the graph will start to rise. And at G, all the liquid has evaporated. So you might be able to guess that at H, this third and final rise that we have on this graph, that would be when the gas is starting to get hotter. And the gas particles move around much faster and move further apart. So again, if we look at the red particles shown on the picture to the left-hand side of this slide, you can see those gas particles are much further apart than they are in the liquid and the solid. There's no fixed arrangement, no fixed volume, no fixed shape. So we have three very distinct phases on this states of matter graph. So this point here to here, we're dealing with ultimately a solid. This region here, we're dealing with liquid, and it's quite clear to see therefore at this point here, we're dealing with a gas. Just one final thing I want to add to this graph, essentially. We can see at point C, when we go from solid to liquid, that would be our melting point. That's the point at which the ice melts to become water, if we were to take water as our example. So C is our melting point. And F, therefore, the point we're going from liquid to gas, that would be our boiling point. So just identify those two on this particular states of matter graph. C is our melting point and F would be our boiling point. So that's just a short video about changing between the three states of matter. We've identified all the processes that go on between solid, liquid and gas, converting from one to another. And we've looked at a very typical states of matter graph with the very three distinct rises and plateaus when we go from a solid phase into a liquid, then into a gas. And we've identified the boiling point and the melting point on this graph and talked about how the particles change during that. Okay, I hope all of that helps.